NEC Article 110.31 addresses enclosure requirements for electrical installations, specifically focusing on minimum distances from fences to live parts. However, its application is limited to exposed live parts. It does not extend to dead front gear or transformers where live parts are enclosed, protected, and inaccessible. Therefore, the 15-foot distance requirement typically associated with NEC Article 110.31 does not apply to an outdoor 35 kV dead front switchboard or transformer. The critical factor is the accessibility of live parts. If the equipment is designed with a dead front, meaning that all live parts are enclosed and inaccessible during normal operation, the distance requirements outlined in NEC Article 110.31 are not relevant. This distinction is important for ensuring that electrical installations comply with the NEC while avoiding unnecessary restrictions on equipment placement. The NEC primary concern is to protect individuals from accidental contact with energized conductors. When equipment is designed to prevent such contact through robust enclosure and protective measures, the need for extended clearances is mitigated. In the context of electrical safety, understanding the difference between exposed and enclosed live parts is crucial. Exposed live parts present a direct shock hazard and necessitate strict adherence to distance and guarding requirements. Enclosed live parts, on the other hand, are shielded from accidental contact, allowing for greater flexibility in equipment placement. The NEC provides specific guidelines for various types of electrical equipment and installations, taking into account the level of risk associated with each. The requirements for substations, for example, may differ from those for general-purpose electrical panels due to the higher voltages and potential hazards involved. Similarly, the requirements for indoor installations may differ from those for outdoor installations due to environmental factors such as weather exposure. When interpreting and applying the NEC, it is essential to consult the relevant articles and tables carefully. The NEC is a comprehensive document that covers a wide range of electrical safety topics. It is updated regularly to reflect advancements in technology and changes in industry practices. Therefore, staying current with the latest edition of the NEC is crucial for electrical professionals. Furthermore, understanding the intent behind specific code requirements is essential for ensuring compliance and promoting electrical safety. The NEC is not simply a set of rules to be followed blindly, it is a framework for designing, installing, and maintaining electrical systems in a safe and reliable manner. In the specific case of NEC Article 110.31, the intent is to protect individuals from accidental contact with exposed live parts. When live parts are adequately enclosed and protected, this risk is significantly reduced, and the distance requirements of NEC Article 110.31 do not apply. It's also important to consult with local authorities having jurisdiction, often abbreviated as AHJ, as they may have additional requirements or interpretations of the NEC that are specific to the region. These local amendments can impact the application of code requirements. They are enforced at the local level and help to address concerns that might be specific to that geographic area. The NEC is also not a design manual, it provides minimum safety requirements. Therefore, one must be aware of the difference between following minimum code requirements and following industry best practices for electrical design. For example, an electrical engineer can design a system that has more capacity than necessary, but that does not violate any of the requirements of the NEC. An important thing to note when looking at an electrical installation is that equipment should be listed and labeled for its intended use. This means it has been evaluated by a testing laboratory to ensure that it meets safety standards. Look for markings like UL, ETL or CSA to ensure the equipment has been properly evaluated. In addition, electrical installations should be performed by qualified individuals who have the training and experience necessary to do the work safely and in accordance with the NEC and local codes. Improper electrical work can lead to dangerous conditions such as electrical shock, fires, and equipment damage. Proper grounding and bonding are crucial for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing overcurrent protective devices to operate and clear the fault. Bonding ensures that all metallic parts of the electrical system are at the same potential, reducing the risk of electric shock. There are several common types of wiring methods used in electrical installations, each with its own set of requirements and applications. Some examples include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, flexible metal conduit, and non-metallic sheath cable. The choice of wiring method depends on factors such as the location, environment, and type of occupancy. Overcurrent protection is essential for protecting electrical circuits from damage due to overloads and short circuits. Overcurrent protective devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. The size and type of overcurrent protective device must be properly selected to match the rating of the circuit and the equipment it serves. Voltage drop is another important consideration in electrical design. Voltage drop occurs when the voltage at the load is less than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for calculating voltage drop and selecting conductors of adequate size. Arc flash is a dangerous phenomenon that can occur when there is a fault in an electrical system. An arc flash is a release of energy in the form of heat and light that can cause severe burns, injuries, and even death. The NEC requires that electrical equipment be properly labeled with arc flash hazard warnings and that qualified personnel wear appropriate personal protective equipment, often called PPE, when working on or near energized equipment. Electrical equipment should be regularly inspected and maintained to ensure that it is operating safely and reliably. Regular maintenance can help to identify and correct potential problems before they lead to equipment failures or safety hazards. Maintenance should include cleaning, tightening connections, testing components, and replacing worn or damaged parts. Surge protection is another important aspect of electrical safety. Surges are transient overvoltages that can damage or destroy electronic equipment. Surge protective devices, or SPDs, are designed to divert surge current away from sensitive equipment and protect them from damage. SPD should be installed at the service entrance and at critical loads throughout the electrical system. The NEC also contains requirements for emergency systems, which are designed to provide power to essential loads during a power outage. Emergency systems typically include generators, batteries, and automatic transfer switches. Emergency lighting is another important aspect of emergency systems, providing illumination for safe egress from buildings during a power outage. One important thing to remember when discussing electrical systems is that all electrical work should comply with all applicable codes and regulations. Failure to comply with these requirements can result in fines, penalties, and even legal action. It is the responsibility of the electrical contractor and the property owner to ensure that all electrical work is performed in accordance with the law. Continuing education is essential for electrical professionals to stay current with the latest changes to the NEC and advancements in electrical technology. There are many different types of continuing education courses available, including online courses, classroom courses, and workshops. Staying up to date with the latest knowledge and skills is essential for providing safe and reliable electrical services. Firstly, consider the type of environment where the electrical equipment is located. Secondly, consider the voltage level of the equipment. Thirdly, consider the potential hazards that exist in the area. These considerations will help determine the appropriate safety measures to take. 1. Always energize equipment before working on it. 2. Use appropriate personal protective equipment. 3. Follow all applicable safety procedures. These practices are essential for preventing electrical accidents. Proper electrical safety practices are crucial for protecting workers, preventing fires, and ensuring the safe operation of electrical systems.